welcome. I understand that we still have people joining in to yet this continuing edition of the Baylor Law Executive LLM in Litigation Management webinar series. Today we are privileged to have with us some people from the Berkeley Research Group, or BRG, to talk to us about artificial intelligence and some of the ethical issues surrounding its use in litigation. Obviously, in today's environment, more and more people involved in the litigation arena are using artificial intelligence, machine learning, and other sophisticated technologies to help with the efficiency and effectiveness of managing litigation. The three that we have with us are Richard Finkelman, Craig Freeman, and Mike Tang. Just a brief introduction about these folks. I will tell you that they have helped in our LLM program, particularly in one of our courses on advanced technologies for use in litigation, and jumping on and updating and providing additional information about the use of things like data analytics, machine learning, artificial intelligence in handling litigation. Rich is a managing director, and he's of BRG. He's nationally recognized technology expert with over 30 years of experience helping clients manage information and technology in the litigation arena. He assists his clients with machine learning and artificial intelligence solutions to complicated dispute-related issues. Craig Freeman is also a managing director of BRG, and he was co-founder of Vista Analytics, and he has focused his entire career on the design and implementation of litigation support technologies, and he also helps his clients with machine learning, artificial intelligence, and other technological solutions for complicated litigation issues. Mike Tang is a director of BRG, and he has more than a decade of academic and industry experience in machine learning, natural language processing, and big data technologies. He, like the others, helps his clients solve complex litigation issues and others with new sophisticated technologies. I'm going to turn it over to these guys. They have a presentation. They've actually done it for some of their clients, and because of their help and work with the Baylor LLM program, we thought it'd be a great opportunity for them to share some of their thoughts about some of what they call ethical issues involved in the use of these technologies. So guys, I'm going to turn it over to you, and I don't know who's going to go first, so go ahead.
Thanks, Kyle, for gracious introductions. I'm going to go first. Gabby, could we get the presentation up on the screen? And I'd like you to go to slide 2, I think. Yeah, this question about AI and ethics, it becomes more profound the more you find out about AI. Everyone on this call interacts with AI on a daily basis. Sometimes you know it, sometimes you don't. But a lot of the questions that people have about, for instance, privacy, I want my data to be private. Well, organizations are collecting your data to use with machine learning algorithms to give you much more tailored responses to your questions on recommendations and restaurants you might like and what have you. And so there's a whole understanding of what is AI, what's it doing, and why does it need my data that needs to be understood. And that's what we're going to talk about today. Next slide, please. So this is what we're going to do today in the next hour. History of AI, subfields of AI, legal technology, adoption of AI, and then there's 4 key principles: transparency, justice and fairness, responsibility and accountability, and privacy. And then we'll talk about the future. Each one of these topics could easily go an hour or so. By nature, we're gonna go fairly quickly through these things. Please feel free to use the chat function and send questions, and we'll be monitoring that, and we'll update you on that as we can. Next slide, please. Next slide. So what is AI? This is a good question. We're gonna go deeper than this slide on the question of AI. The first thing to understand about AI is that it's not something specific. There are probably 20 subfields of AI that we care about. This shows 4 of them: machine learning, natural language processing, robotics, and computer vision. And then deep learning is a subset of machine learning. Mike Tang, who has his PhD in AI and is our chief data scientist, will handle this topic in a bit more detail as we go through the through the slides. Gabby. So I think this is it's not a visually attractive slide, but I think it's an important slide. If you look at all these things, all of these are part of artificial intelligence. There is no one thing in artificial intelligence, and the areas that we focus on in disputes and litigation mainly are machine learning and natural language processing, the top 2. It would seem that expert systems would be something, but it's not used that much. Speech is not used that much. Robotics is hardly used at all. And we really focus around predictive analytics and deep learning into machine learning. And that's where we'll focus most of our time today. Next slide, please. Okay, so we're going to do a history of AI all in one slide. It's interesting that it started at Dartmouth College in 1956. And the whole focus of AI at that time was what is called conditional logic, which basically means if you can write a statement of if X happens, then Y happens, else Z happens. And you would line up hundreds, and people tried to do thousands of those conditional logic statements to create an AI. And it didn't work. It didn't work at all. And so you see at the top, 74 to 80 AI winner. Nobody knew what to do, and so kind of gave up. You'll see in 87 and 93, there was another AI winner where people had tried things and it wasn't working out. The 1998 to 2011 computational power, data-driven, a lot of that is around the public cloud, which gives almost anyone infinite amounts of processing power, as long as they can pay for it. And so just as a brute force method, that's what was happening. And then in 2012 to today, you'll see it says neural networks and deep learning. And what happened is the creation of algorithms, which are models basically, that can learn on their own without being explicitly programmed to do such things. And that transformed AI from what was sort of a kludgy thing back in the 50s, 60s, and 70s into the powerhouse that it is today. That's the fastest short history of AI that you'll ever hear. Next slide, please. I'm going to turn this over to Mike Tang. In addition to what Kyle said, you should know that Mike is our chief data scientist for Berkeley Research Group and has his PhD and is really one of the, I've worked with him in a couple organizations, and he's one of the world's leading experts in these topics.
Thank you, Craig. So I think the key information on this slide is what you can see on the upper right corner, the difference between traditional programming and machine learning. So in the traditional programming, like for example, in SQL, you have your data stored in a database, and then you write some SQL query, and the SQL server execute your script, and you get your output. That is what the traditional programming way. In machine learning, it's the opposite. You get your data, and then you get your output. For example, you may have your loan application as your data, and then you have the application results reject or approve as your output. And then you enter that into the computer and let the computer figure out the program. So then going forward, the computer can make the decision on behalf of you. So that is what the biggest difference between machine learning and traditional programming. And also,
and Mike, if I could just add in there. So I think an important point for all of you is that in traditional programming, you have to know what you're looking for and run a query to get it. In machine learning, certainly for like fraud detection, you don't have to know what you're looking for. You give it examples and you give it a framework, and it can go find things without you explicitly telling it what to look for. Like,
Yep, I think you summarized that pretty well. And then also on this slide, you see the difference between machine learning and deep learning. And deep learning become very big thing in the last 8 to 10 years because of this new development and also the GPUs and everything. So that is the tool that empower people to process very sophisticated data like image and natural language processing as well. Next page, please.
So these are some of the applications of AI that we see in our everyday life. We all interact with Google, Netflix. We've all had the experience of shopping online and later having what we shop for show up in a social media app. So we're using AI in our daily lives, and it has a lot of applications. And the point of this slide is just to give you an idea of all the different areas where AI has a spoke in a wheel here. And we just call out healthcare, finance, and manufacturing as examples of where we can see AI applications at work. You go to the next slide. So one of the things we would like to talk about is the legal technology history, just to give a baseline of how the industry has adopted technology. What you see here is a chart of technology adoption. It's a fairly famous chart for how people actually in different groups adopt new technologies. And there's always the innovators and the early adopters who will try anything that's new. But most of the market in any application world are pragmatic and conservative, and they don't adopt as quickly. Lawyers have typically been early adopters of technologies that help them. WordPerfect is a great example. Document management programs that law firms started using 30 years ago is another good example of where technology was so obviously beneficial to the legal industry that lawyers were early adopters. But you pay a price sometimes when you're an early adopter. And for everybody who loves WordPerfect, they were sickened when Microsoft took over corporate America, and Word and the Microsoft suite of applications, took out all the favorite technologies. And we say that in context here because what you'll see is that AI technologies have been fairly early adopted in litigation technology, but not so much with the rest of the legal industry. So we haven't yet seen mass market adoption of any AI technologies, except in high volume e-discovery matters. And you can go to the next slide. So we're going to talk about go back just so I can set so there's 4 principles, and Craig hit on them, that we want to talk about. There's more than 4, but the 4 that we focused on in putting our heads together and putting this presentation together are transparency, justice and fairness, responsibility and accountability, and privacy. And you can go to the next slide. And just to set the stage for this, right, there are a number of competing organizations. There's the private sector, there's government regulatory bodies like the European Commission. There's a lot to discuss in terms of what people are doing to try to put guidelines and guardrails and to deal with some of the issues involved in AI and ethics. You go to the next slide. So the first section we're going to talk about is transparency. Go to the next slide. And Craig, this is you.
Yeah, transparency is an interesting thing. And the idea behind transparency is that you understand how AI, machine learning works. and we have a bunch of bullets here, and it is not easily determined what is going on within an AI system. What machine learning does is it goes and finds patterns in information, and then it is able to predict something based upon those patterns. But it doesn't come back and say, these are the patterns I used to predict something. What machine learning does is if a data point predicts something, it's used in the model that machine learning uses. And if it doesn't predict, it throws it away and ignores it. So you can see the benefit of higher transparency, which is to verify predictions and identify flaws and biases. This is a very new stage of machine learning and AI, which is to be able to explain what happened. So you're in Amazon, you're looking through your recommendations. Why were they recommended to you? Sometimes I can easily see why. It's the same subject matter, it's the same topic. But other times I have no idea what the system is doing. How does it know better than I do what I would want to see, what I would want to do? Right now, we rely on a couple different things, and then I'll turn it over to Mike. We rely on understanding how the algorithms work, what they're trying to do, and then we use statistics to uncover what are the patterns and what are the what is happening behind the scenes from a statistical point of view. And this is really important to lawyers, in that if you're using AI, one of the things that courts want to do is understand how you came to the conclusion you came using AI. And we think, for instance, and Rich talks about this at length, we think that having good fact witnesses that understand what's happening in the system and can explain it, and having statistical conclusions that you can show to the court, goes a long way to being able to have it the information as admissible. Mike, do you want to talk about the glass box and inference? Can't hear you.
Sure.
Mike, you're on mute.
Yes. So as Craig mentioned, well, transparency is likely the most important principle in AI, and in order to safeguard AI, the foundation is to understand how it works. So for the glass box approach, is just by design, you're trying to design a transparent AI system, like a glass box, where you fully understand the structure of the system, which is very difficult, if not possible, if not impossible. Another approach is that you build explainers. So you build a model to explain your model. So there are certain techniques that you can use that can make that happen without holistically understand the entire AI system. So those are the two main trends people are working on right now. So nowadays, if you go to any of the AI and machine learning conference and you see these models people propose, and you will also at the same time see that they will try their best effort to explain their model outputs. That is a very different things comparing to just like 2-3 years ago. Before that, like no one cared. They only care the performance of the model, but nowadays people care also whether you can explain the output of your model.
Next slide, please.
So
Mike.
I believe this is example where researchers try to decipher how AI make prediction, and they found problems. Like if they didn't do this exercise, they won't understand the issue of their system, which will introduce bias downstream. So here, this model is people trying to train a model to predict the label of an image, right? Whether this is a cat, a dog, or a horse. The researchers found that the model performs extremely well in the horse category, and they want to understand why. It's almost like too good to be true. And then from a post hoc analysis on the decision making, it turns out that the model is picking up a watermark on the left corner of the horse image here. So instead of really understanding what a horse should look like, as you can imagine, if a system like this is deployed, it would not perform well in the real world application. So this example showcased the importance of transparency in model development, and also you won't be able to decipher a system as complicated as this one back 5-6 years. So this is a new techniques that people develop lately to just trying to explain their black box model.
You know, Mike, one of the first projects I worked on in AI was comparing algorithms to rules-based systems. And so the professor said, so a rules-based system, write the rules down that, this is very simple, a 2-year-old can do this, write the rules down that are able to differentiate between a cat and a dog. And I couldn't come up with one rule. They both have tails, they both have ears, they're both furry, round faces. I mean, what differentiates a cat from a dog in terms of rules? But in machine learning, you give it enough examples and it figures out what's the difference between a cat and a dog in the same way that a human child would, not in the way that a 27-year-old computer programmer would. Next slide. So I need to move my stuff around so I can see here. I think what I want to look at is the graph on the right, and nobody needs to pay attention to what a neural net is or a Markov model or a decision tree. The conclusion here, though, is that if you look at the trend of the dots, it's more explainable. The models are more explainable, the less accurate they are. And the more accurate they are, the more complicated they are and less explainable. And so there's an inverse relationship between explainability and prediction accuracy that people need to understand. And that's just an example from today. Mike, if you could talk a little bit about fair washing and what that is, and then I'll pick up from there.
Sure. As Craig mentioned, for complex model, although it works better, but it's harder to explain, right? Because of so this phenomenon motivates some explainer models that motivate the development of some explainer models, right? So people trying to develop model to try to explain this black box. However, by and large, AI is still a black box. Although you can, so how can you make sure that your black box is non-discrimination, right? And then even though you can build some explainers, but these explainers are just approximation which tries to explain your black box as much as possible. They are not perfect explainer, they're just trying to approximate your black box. Then there's a problem. You can build multiple explainers and cherry pick the one that you like. As you can imagine, someone who eager to deploy their models might simply pick a explainer that seems legit and comply with certain ethical requirements. And this is called fair washing.
You know, we had a question, guys, and it was exactly what was going through my head as y'all are talking, given what's on the right side of this page. If we can't explain the models in the litigation setting because of their high prediction accuracy, how does anybody really know if they're accurate? And I guess I would add, isn't that going to be the expectation of the court when you're using these types of models within the court? I'm justifying giving you these documents, or I'm justifying doing this because my artificial intelligence model says this is right with a high degree of predictability? Well, the court's going to say, okay, how do I know that?
So let me take a stab at that. It's an excellent question and kind of what we're trying to get at. I find that there's twofold what we try to do. One is that we try to use statistics and testing so that you can show how accurate it is, and you usually do that as a comparison to what humans are doing. There is a sense, if you're thinking about document review, there's a sense that an attorney's eyes are the gold standard for what's correct and what's not. And I would agree with that, except that it's got to be the right lawyer at the right time, not multitasking, fed correctly, good night's sleep, not hungover. Then that makes a lot of sense. But if you think about using AI to do doc review, what you do is you run a test set, and you have maybe 3 or 4 lawyers that are excellent that create your test set, and then the machine learning learns from that, and then you test them and produce a statistical report, and as a comparison to humans. Secondly, I think you need people like Mike Tang here that can be fact witnesses, that can say, this is what happened, this is what we know, this is what we don't know, and use that as a comparison on time and money also.
I would add a couple things to that, because Kyle, it's a great question. We're going to talk about it a little later in the presentation, but fact witnesses and science days. We see now that cases that involve a lot of AI, courts will have a science day prior to the case getting started, and have technology experts come in and educate everybody on what some of the underlying issues are. And I think a good example of what Craig's talking about is the use of statistics in something like privilege review of documents, because you can use AI to predict the likelihood that a document is privileged. Then the issue is, okay, what happens at what point have you predicted enough to be substantially compliant? And do you have things like a clawback agreement? And we worked with a client, and they got to a point where we sat down and they said, how many more documents do we have to review to get to 100%? And we told them, how the machine would model it out. And we then did some statistical and analytics and said, okay, if we stop at 95% certainty, and there was a clawback agreement in place, and we can prove it with statistics and the math behind how we got here, then we were all comfortable going into court and defending that that's the actual process that was used in explaining it. Kyle,
the other thing that's really important to understand is that and we're going to talk about this in a little bit, but there are emerging standards in terms of what needs to be done. So, for instance, if you're using predictive coding to the Department of Justice, they demand that you have a recall rate of somewhere around 75%, and they've got a precision number also. And so no thinking person is saying this has to be 100% accurate, because that doesn't exist. But what you have to do is show appropriate rigor, appropriate testing, and appropriate commitment to getting a good result. Kyle?
Well, I mean, go ahead. I'm still contemplating.
Okay, we go to the next slide. So this touches on some of the stuff that we've been talking about, but there's a real need in the industry for AI experts. And think of it in 2 ways. There will be cases where the actual expert is an AI person because the underlying issues of the case involve AI technology. There will also be instances where it doesn't have anything to do with the case, but it may be that a damages expert has done all their economic work and is using some models to predict damages and losses. And that expert is not a data scientist and not somebody that actually understands how machine learning works. and then you would need a fact witness person like Craig was mentioning earlier. One of the things that we see is that this push and pull between regulatory lawmaking bodies and what companies are willing to provide in this transparency arena. And for obvious reasons, right, that companies, have IP and they don't want to give stuff out unnecessarily. But here are a couple examples where, there's technology underlying issues that had to be addressed by regulatory and lawmaking bodies. And you can go to the next slide, please.
Wait, stay here for just 1 second. The other thing that I would point out is that if you're thinking about document review and thinking about machine learning versus humans, I would argue that you should be statistically testing how well you've done with humans the same way you would with AI. And I think that has, in my experience, that has not been done often enough, unless you're in some sort of challenge kind of state. And so there's an expectation that people have around humans versus AI that isn't grounded in reality.
Well, I would say that, it reminds me of the game that you play with a kid. Okay, when you're a kid, you sit around the campfire and somebody whispers something to the person next to them in their ear. And by the time that statement goes all the way around, it is vastly different than when it started. And so sometimes
Exactly.
when humans do privilege review, there's an instruction that's given from somebody, and then that instruction goes from that person to the next person to the next person. And by the time the instruction gets to the last person doing the review, the instruction itself may be different. So therefore, you're going to have errors because of the difference in instruction that each person got along that chain. But go ahead.
And you're not only are you right to bring it up like that, lawyers write differently than other people, and it's it's actually a safer and easier task to model the writing of lawyers on a particular project than it is just to do keyword searching for privilege and confidential and anybody who's a lawyer. And you actually get to train the machine so you're looking at, as you say, something that was actually said as opposed to instructions from somebody handed down 3 times.
And it's things that people don't have any consciousness of. Lawyers write different numbers of words than lay people usually in a sentence. They use more syllables than lay people do in a sentence. And so it's these unconscious things that because lawyers are so focused on precision in language, that comes up with a different writing style that identifies privilege.
And here I want to add one more comment. I believe there are 2 concepts here. One is, and I don't want you guys to confuse about these 2 concepts. One is whether the model is accurate enough. Another one is whether the model can be explained or transparent enough. Right? So whether the model is accurate enough can be tested or verified by some statistic test out of sample test. And whether the model is transparent enough is something that computer scientists is working on. So I have a feeling that without knowing the model is transparent or not, that doesn't hurt us or wouldn't stop us from using the model if we know the model is accurate. However, because of the development, because the pace of the development of this technology, if we couldn't explain the model well, then in long term, we will end up in troubles. And that's why we have a higher standard. We not only want our model to be accurate, but also want them to be explainable. That can make sure that machine learning has a long way to go. So that are 2 different concepts.
Great, thanks.
Good, Mike.
Okay, we can go to the next section. So we're going to talk about justice and fairness. You go to the next slide, please.
So I'll jump in here. Justice and fairness, it means the prevention, monitoring, or mitigation of unwanted bias and discrimination. The Washington Post had an article about a year ago on a George Washington University study that was using using AI to evaluate something about labor, and statisticians looked at it after they got the result, and they came back and said there's a huge amount of bias in the conclusions here, especially around race. And then the data scientists came back and said that's impossible. We didn't ask any questions about race, so how can we have bias in there? The reality is that it's very simple. If you think about non-AI applications, we have worked as a society for hundreds of years to correct our systems so that past wrongs have been dealt with. This is not an argument for or against welfare or what have you, but it is saying that we think that there was a societal injustice done previously, which we have made as factors in how we're evaluating whether you get into a school, whether you get additional money or not. And if you think about AI, if you're just letting it run and don't factor in those societal imbalances that historically have been there, you're going to see those imbalances again. And it's going to appear, whether intentionally or not, it's going to appear as though there is bias in the data and that you haven't corrected that.
Craig, I go back. So the other thing that we talk about is the impact on the labor market and whether AI is going to, how it's going to disrupt it. And I'm going to use your example, Craig, which is that, when spreadsheets first came out, it was predicted that jobs would get lost because who needed accountants to manually do anything anymore when you had a bunch of spreadsheets. And in fact, the accounting labor market exploded over the last 30 years, and technology did not have a negative impact on that industry.
And to be a little more specific, accountants as a percentage of the labor market are now 3 times what they were pre-spreadsheet, and counted to everyone's anticipation. And think of, and it makes perfect sense once you think about it. Think about all the things we can do with spreadsheets and accounting now that we couldn't do before. We couldn't do forensic accounting. We couldn't build models in different business scenarios and all the things that go on in finance and accounting departments now. And we think, and we hope, but we think that that's what's going to happen with the AI labor also. That we'll be doing things in ways that we can't anticipate at this point in time, and that we didn't realize were accessible to us.
Go to the next slide, please.
Who is this? Is this me?
Yeah, go ahead.
The number one challenge is that AI applications reflect the bias of the programmer. And so you think you're programming this to be neutral and to not introduce bias, but it's almost impossible. Just because we're humans and we introduce bias to almost everything. And the second point is it's going to be a structural change to the economy. And it may hurt a group of people, but a net gain to the whole of society. And if you think about, the issue of coal mining, no matter where you stand on it, there's less and less coal miners. But as that's dropped, a whole new breed of technicians on solar and wind farms has been created. And so you have to look at it in its overall scope and not just say, we lost 100,000 jobs in computer programming.
We'll go to the next slide. Mike, do you want to talk about the different types of bias?
Sure. Yeah, so this slide summarized different kinds of bias that AI might encounter. So, and as you can see, the bias can be everywhere. You may have some historical bias, which refers to the bias that have been embedded in our society or in our data. For example, if you're trying to train your model, use pre-COVID data and then apply your model during the COVID period, then your model may not be accurate. That is what's called a historical bias. And you may also have representation bias in your system, which occurs when the data that you use fail to represent the population in a balanced way. For example, you don't have enough observation from the minority group in a clinical trial, right? So you don't represent your population, so your model will fail. You can also have measurement bias, which means the outcome of your faulty measurement, right? So a simple example is like, if you're doing computer vision and you have a camera with a chromatic filter, which will always generate images with a consistent color bias. And when you take that bias into your system, and then your result will be skewed. And you may also have something called aggregation bias. For example, you might have data showing that the inner city students tend to be perform poorly on standardized tests. And that doesn't mean any one individual will perform poorly. Likewise, you may show that, say, one particular state has a lower than average per capita income, but you can't say for sure that every county in that state has a lower than average income. And you definitely can't say that every person in that state has a low income. So if you're trying to extrapolate from a group to an individual, then you introduce this aggregation bias. And you will also have evaluation bias in your model if you forget to evaluate the fairness of your model. If you only look at how accurate is your model, but forget about the fairness part, then you will introduce evaluation bias into your AI system. And at the end, you may also have deployment bias, which is when you use your model in a off-label fashion. For example, you build model intended to predict a person's likelihood of committing a future crime. However, you use the model to determine the length of a sentence, right? If they have a higher chance to commit a future crime, the longer the sentence. Well, this is off-label usage, and this will introduce deployment bias. So as I said earlier, there will be a lot of factors eventually impact the performance of your model, because there are many different kinds of bias could be introduced into your system by accident if you don't pay attention.
But this appears to me, Mike, to be it's a troubling area to listen to in the context. One of the questions that came up was, this is sort of the quintessential junk in, junk out, and what I think being meant by that is that if you're trying to predict some future course of events based upon data that's internally biased, then your prediction is off on the basis of that bias. If you take people where they are or circumstances where they are and try to predict something into the future, where people are right now includes historical biases and prejudice and things of that nature, which I think is troubling for people as we move forward in the use of artificial intelligence. And I think this issue that y'all are addressing right here is a major significant issue that has to be addressed in the real world that we live in.
Kyle, if I could, I agree with what you just said completely, but I am encouraged that we're having sessions like this and talking about bias and the need to be highly focused on it and testing for it. There are biases in everything that people do. And frankly, I think that our industry is spending more time trying to quantify those things and cancel them out than in other areas where there are huge amounts of bias and people just, ignore it.
I know we're running somewhat closer to the time frame. You got two other things to go to, so I'll try not to interrupt any
Yeah,
okay.
anymore.
Next slide. So to just wrap up this section, is the trade-off of decisions and ensuring fair and equal treatment. One thing we haven't talked about very much, and we'll just touch on it here, fair access is a big issue for justice and fairness. And as an example, what if somebody has access to technology that another party doesn't have access to, just because they can't get on the internet, or because one party has access to an AI generated contract system and another party doesn't, right? And so the issue of fair access has also got to be thought of here in justice and fairness. And then how do we address and remedy problems? As Mike pointed out, in the criminal justice system, that's a big deal. Can we go to the next slide? So we're going to talk about the third principle, which is responsibility and accountability. Go on. And what it means is clarifying the attribution of who is responsible. So, through transparency, you start to see, okay, here's, here was what it was at play. Here are the algorithms. Here's who did what. And, it needs to be clarified. Was the fault a bias of the development team? Was the fault the data? Was the industry, not taking accountability? So there's different areas, and if you go to the next slide, we'll get into a little more discussion about what's going on. And Craig, you and I can talk about this briefly, but there is a lack of a fiduciary relationship between AI developers and the public. And in the example that I think I mentioned earlier, it's somewhat troubling to all of us to search for something that maybe we don't even need. We're looking at something for one of our parents online, and then, within 12 hours, a different company altogether is showing you ads for that product. And we don't understand how all that stuff works. So
I think my example here is if you think about self-driving cars, where's the responsibility and accountability? Is it between the car owner? Is it between the software developed? Is it behind the Google GPS devices? Where does the responsibility and accountability lay? And these are questions. By the way, we should have explained up front, we're bringing up what are current issues that need to be pondered. We're not giving you the answers to what these things are, because the answers haven't been decided yet. And I fearfully think something like self-driving cars, which seem like a huge benefit to society, might not happen because we can't agree on who's responsible for it and who's liable for it. That would be a very bad outcome.
One thing we do talk to people about, and we do see a growing need for this, you'll see the last point here on ethics committees and AI people involved. We think there's a role for an AI ombudsman in organizations. And that as people talk through how we're going to make people accountable and who's responsible, that the ombudsman function is a good place to look for some transparency and some ability to talk to the issues of responsibility and accountability. You go to the next slide. And Mike, I think you were going to talk here a little bit about what makes something truly autonomous.
Yeah, I think there's always a debate about the responsibility of and the accountability of AI if AI itself is not explicitly programmed by their creators. It learns things from user behavior. It learns things by interacting with people in the real world. So the example here is like if the AI picks up a bad driving behavior through day-to-day interaction and ends up in a car accident, is it fair to only blame the company who manufactured the car? Also, the user also need to, there's some responsibility attributed to the user as well. So similarly, in 2016, so Microsoft released a chatbot that can interact with Twitter users and get smarter through interaction. However, it took less than 24 hours of this chatbot to become a fully racist because people tweet the chatbot with all sorts of racist remarks, right? So I think that just like one example for make sure that people need to think about who created AI, who trained that, and then need to consider what's a fair way to attribute the accountability.
And these are questions for all lawyers and all of society. This is not for computer programmers and data scientists to figure out. They'll have input also, but it's a broad societal question. Next slide, please. Go one more, please. So this is what I mentioned earlier on. Data is fundamental to AI development. If you think about AI simply, what you do is you look backwards at data for 5, 10, 20 years. You create a model backwards, and then you use that to predict the future. So you need data for AI to work. You need historical data. And some of us are very glad to give AI historical data, and some of us are very loath to do it. And the question is, I think law and regulation is right. You know, where HIPAA and GDPR have worked successfully, it has put rules around how the data can be used and how it can be shared. Mike, did you have anything you wanted to add there?
I think the next
Okay,
slide.
let's do the next slide.
Yeah, the next slide.
And this is just more on that question. I don't know if you had this stuff you wanted to add here, Rich.
No, I think we've talked about it.
Okay.
We have a question.
Next slide, please.
We have a question that came up in the chat, and it's a question on the comment that I made about unequal access to AI. And the question is, will AI technologies in the litigation context further increase the cost of litigation and put it further out of reach for the average person / company?
We like to say that the correct use of AI does 3 things. It reduces the timeline, it reduces the cost, and gives the user insights into the data that they might not be able to think of and search for. And so as opposed to broadening the gap between haves and have-nots, we think it can successfully use to narrow that gap. Rich and I worked on a case some years ago. I won't mention the client, but the defendant had 800 contract programmers working for 18 months reviewing documents. A huge amount of money was spent to do that. And today you could probably do that with 5 reviewers and the correct use of machine learning.
It's a fair question, though, on the one hand, because you know, I could foresee ESI disputes, which the courts have you know, been loath to deal with and have pushed back on people to solve themselves through meet and confers. But I can see that at some level you could have a client make the argument that they don't have access to the same technologies that the opposition does, and that in some way they're harmed in an ESI context.
Yep.
Yeah. So it's a good question. Okay, so go to the next slide, please, because we're going to wrap up here. So one of the things that we want to talk about in terms of the future is, you know, how we see, and Craig made a good comment, we don't have the answers. There are a lot of issues that are obvious to all of us now, but not a lot of answers. And so, you know, there's push and pull between companies saying they'll do self-regulation versus, you know, who's going to be involved in legislation. Those of us who live in DC, Craig mentioned the Washington Post. I can't tell you the number of Sundays in the last couple months that Facebook has taken a full color page in the very first section saying that they are for legislation. They are for oversight and supervision, and that they want to work with the public on privacy and make sure that people are comfortable with it. So we think that you're going to see more of that. But this whole issue, is complex because there's pros and cons to both. You want to add anything to that, Craig?
No, I think that's good.
Okay. And go to the next slide. I think we're wrapping up. You want to talk about this one?
Well, I guess I would just say, first off, that anybody that wants this set of slides, we're glad to send them to you, and you can look at them in more detail. AI has been transformative so far in the last 10 years in significant ways. But our thought is that it's also very preliminary, that it's going to change more than we think. And right now, every type of AI has been specifically designed for a specific issue, a self-driving car, you see home service robots, whatever. And nobody has ever built a generalized AI, an AI that can look at a problem and figure out what to do the way a human would. And those sorts of things will be coming, and where that will take us in robotics and what have you is pretty exciting, I think.
And we have one last slide. Go to the final slide. So one of the things we talk about is, how quickly will the legal industry, adopt stuff and start to look more like the medical field. And you can definitely see, particularly that, COVID has changed for us our view of telemedicine and some other stuff. But the medical field has some of the things like review committees and licensing and HIPAA that are underpinnings of how you go do this. So
I think also that prior to COVID, no vaccine was calculated for a virus in less than 4 years, and all the major pharmaceutical companies used machine learning and AI in significant ways to get us to where we are on COVID vaccines. That's the promise here. We're talking about lots of concerns and lots of issues, but that's been a major positive.
And let's wrap up with one thing. And I think you guys have seen they put the CLE code into the chat. Our very first slide had a picture from the Terminator of a robot that takes over the world. And Craig and I took a course a couple summers ago. And the professor made a point that it's easier to land a rover on Mars than it is to get robots to do anything here on Earth, like clean your dishes or pick up after you. So we're a long way away from robotics taking over. We want to thank everybody. This has been great.
Yeah, let me say this, Richard, Craig, and Mike. Thank y'all for just a very insightful and thought-provoking talk about artificial intelligence and these issues that you raised. It certainly has piqued my interest and my curiosity as we move forward. And I certainly like the sort of the future slides that you put up about what it looks like in your comparison to the medical arena and others. And what a great sort of talk that y'all gave us today. And folks that are participating in this webinar, on behalf of the Baylor Law Executive LLM and Litigation Management, we want to thank these fine people for their help and their participation with our candidates, our students who are in our LLM program, helping them understand artificial intelligence and how it's used in litigation, how you take all of the data that we talk about in the data analytics course and how do you use that in the context of litigation. I know that Amy Falcon asked the question about, is it going to make it more costly or separate people, the haves and the have-nots? And I think the intent here from a litigation perspective is to make the litigation arena or help make the litigation arena more effective and more efficient, quicker, better, those sorts of things. I think that's what the goal is here, so that the court system and the judicial system and the jury system is open and available and accessible to all people, equally as we move forward. And that's one of the intents of the program that we run down here at Baylor. If you're interested in the program, please contact us and we'd love to hear from you. And I know that BRG would certainly love to hear from anybody who's interested in what they do and how they do it and their help in the litigation arena. Again, guys, I can't thank y'all enough. Thank you for your support of us and for this great presentation. Very nice. Thank you so much.
Hey, Kyle, just we're getting a number of questions about how to get a copy of the slides. We're going to have one of our people reach out to each of the attendees and ask if you'd like a copy of the slides or not. So
this video will be posted, and it'll be available. I believe it'll be available on the Baylor Law Executive LLM website. So the video with the slides included, it's been recorded, will be available for continued access and use. So good. All right.
Thanks, Kyle. It's been a pleasure.
Thanks, guys. Appreciate it very much.
Thank you.
Take care, guys. See you.
Bye.